Hello, and welcome to the day 6 lesson that we're going to look at today. But before we do that, it's been requested that I work out problem number 2 with you. So the first thing you want to do is go to your calculator and clear all your lists. That's number 4. Okay, so now that that's done, you're going to go into Stat and Edit. Go to L1, and you're just going to start typing in these numbers one at a time. I'm going to be typing them along with you, but you just type them at your own pace. You pause if you need to do that. Okay, so at any point, if you need to pause, you just pause. So hopefully everybody's doing okay with your social isolation the last couple of days. I'm sure at this point your parents are making you crazy. I know I am doing that to my son. He is not enjoying me being home all the time and helping him, quote unquote, with his homework, because mainly that means I am helping him to get a lot more organized than he would like to be. Yeah, this is the fun part of the video. Okay, so I know that I've put in the correct number of data points, 44, because when I look down here at the last little spot where it says dash, 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 it says 45, which means I've inserted 44 data points, even though I haven't made a graph. Okay, so it says make a histogram. So I'm gonna go over to Stat Plot. I'm gonna pick the histogram option that's right there. I'm gonna change my frequency back to 1, because I'm not doing list 2, and then I'm gonna hit graph. Oh, I don't see anything. Zoom 9, and there is my histogram. Now I've got some choices with this. If I were making this histogram by hand, I would probably count by 5s. So I'm gonna come over here and make this into a 10, and then I'm gonna change my X scale. Instead of being 6.666 units, which I don't even know what that is, I'm gonna change it to 5, and then I'm gonna look back at my graph. Now when I hit trace, you can see that your minimum is 10 to 14. Notice it doesn't include 15, and there's 10 items in each box. So you should be able to get a nice picture there. Next, it says write a paragraph describing your data. Now, of course, you already have the answers for that if you've looked ahead a little bit. But if you go over to one variable stats, again, change that to a 1. I think that should work. Oh, no, hang on. I just need to clear that out of there. There are my statistics for this. I can scroll down if I would like something that's below here. So notice there's a little arrow. What if the arrow disappears? Do one variable stats again and it'll reappear. Now, what if you still cannot get your calculator to work? Call these guys at 1-800-TI-CARES. That's for Texas Instrument Cares, and they will help you out with all your calculator issues. So hopefully that one is okay now. All right, so moving along, let's take a look at the stuff for today. So for today's stuff, you have been given a set of data up here, which you now need to enter into your calculator. So just like before, I'm gonna do second memory, and I'm gonna clear all my list. So now I'm gonna go back into Stat, and I'm gonna start editing. Now all the dark numbers that are at the top are the actual test scores. No one made a 1. And down below that is your frequency. So this is gonna be your list 1, and that's gonna be your list 2. So let's go ahead and let's enter that in. Pause as you need to make sure that you have the correct numbers that you're putting in your calculator, and you take as much time as you need to do this. Okay, So let's go back and take a quick look, make sure that we have all of our numbers in correctly, going across before you put your frequencies in. Okay, so that looks really good. Now let's put in our frequencies to go with that. So right arrow and put in your frequencies. Okay, so now we're ready to go make our graph. First thing it asks for is a modified box plot. So you're going to go to stat plot, which is that first one where we just were, and you're going to go over to type, and you're going to pick the box plot that has the two little dots next to it. Now it's going to ask you what your frequency is. Now because we used L2, we're going to type in L2. L2 is right above the number 2. And then we're going to hit graph. Oh no, I don't see what I want, so I'm going to hit zoom 9. And there's my graph. Okay, now when I'm making my graph on my sheet of paper, I need to put a scale on it. You can't just draw the picture and hope for the best. So we're going to go over here and we're going to hit trace. And this will tell us that our smallest value is 68 and our smallest is 87. So I'm going to start here with 65, 70, 75, 80, 85, 90. And notice I'm trying to keep those, like there's a similar amount of space between them. All right, so to make your box and whisker plot, the first place you need to graph is the 68, which is about there. Then you need to graph a 75, a 78, a 80, and then finally an 87. Make your box. And there's my whiskers. I kind of overshot that a little bit. Okay, so there's your box and whisker plot. Now it says make a histogram. So let's go in and let's change it to a histogram. Still leaving list 1 and list 2. And I'm going to hit graph. All right, that doesn't look right. So I'm going to go to zoom 9 and let's start there. Okay, so in order to make your histogram, there's a couple of different ways you can do it. You could leave it like this. If you notice when you hit trace, you've got some weird numbers down there. Or you can go to your window and you can change things. Now, I'm probably going to leave this so it matches with what I did for the other graph. So I went up to 90. So notice I'm making my numbers pretty. Now for your X scale, you can do your X scale by 1s, 5s, 2s, 10s, whatever you want, but you probably don't want to use 2.7. So I'm just going to pick 1. Now I do know that that's going to make my Y not be tall enough. Let me show you what I mean. Oh, okay, so it does look fine. All right, so my Y looks fine. So now when I hit trace on my graph, if you notice, that says that there's one item in that box from 68 to 69, in other words, 68. So at this point, I'm going to move my calculator over to the side, and I'm going to make my chart. Now, the highest value that I have on my chart, if you scroll across, it looks like it's a 7. So when you're doing this, you want to make your scale on your side 1, 2, 3, 4, 5, 6, 7. That's your tallest. All right, so at this point, it's just a matter of making your graph. So let's see here. I'm going to start with 68, 69, 70, and you just keep going across, doing your numbers. 1, 2, 3, so 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90. Okay, so using the chart that I have in front of me, I'm going to say that there is one item at 68. Then there's a blank spot. Then there is one item at 71. Sorry, 70. Then there are 2 items in the next block. Then 2 items again. Then 3 items. And you get the idea. You just keep making your graph going all the way across. When you're finished with your graph, it's going to look like that little beauty right there. Now the reason those numbers are appearing is because these were made in Excel. Excel does that for you. It's just kind of a nice feature of Excel. So the next thing it says to you is, I want you to go make a normality plot. So what the heck's a normality plot? It's a plot that shows you how normal something is. So you're going to go up into stat plot, and you're going to go all the way across to make your normality plot. And you're going to hit graph. Now I'm going to hit zoom 9 just so it spreads out real nicely. Now if this line that it shows right here is perfectly straight and all the squares are evenly spaced, it's going to tell me my data is exactly normal. Now you can tell from looking at here that this data is pretty symmetric, but there are a couple of gaps in here and the 2 sides aren't exactly the same all the way across. So since that's the case, it's not perfectly normal. So you'll notice the explanation says the normality plot looks like a straight line. This suggests the normality plot with a straight line is approximately normal. So since that looks pretty straight, we're going to say it's approximately normal. All right, now down below that for number 3, it says fill in this chart. Okay, so all of this chart stuff can come from one variable stats. So go to stat, calculate, one variable stats. Now we are using a frequency list of 2, so I'll do second number 2, and then I'm going to calculate. And at this point, it's just a matter of filling all that stuff in. So let's see here, my sample size is 61. My mean is 77.5. Let's see here, I have a standard deviation of 3.8. Now I'm using the sigma one, which is down here, not the S with a little X next to it, okay? But I'm rounding. Then I've got my minimum, that's 68. I've got 75 for my Q1. I'm going to use my down arrow. Median is 78. My Q3 is 80. My maximum is 87. So notice I'm getting all of that off of there. Now the range, that is your maximum minus your minimum. So we're going to do that subtraction right there. Let me quit off of this screen and go back to my home screen, because I always want to make sure this is right. So 87 minus 68, that is 19. And then I also need my IQR, that's Q3 minus Q1, so 80 minus 75, and that's 5. Okay, so that is all my information filled in from my calculator. So it says, what do you notice about the mean and the median? They are almost the same. So if you're looking at that, here is your median. Here is your mean. As you can see, they are 0.5 apart. That is almost the same. What does that suggest? The data is fairly symmetric. You could also say it's approximately symmetric. You could say it's almost, you know, there's just so many options right there. But what you're trying to say here is that you realize that since those are similar, that means your data is symmetric. If those are not close to each other, that means your data is skewed. Okay, so now we're moving on to the next page where it asks for some descriptions. So if I'm looking at number 5, my context, these would be the unit test, scores for 2 econ classes. Okay, so that's what the problem's about. Shape, I'm going to say this is approximately symmetric or approximately normal. Remember our normal plot? It looked really good. Okay, so unusual, there are no outliers. There were 2 small gaps. At the bottom and the top of the range of the data, so at the 2 ends. Okay, center, remember we said it was symmetric, so we are going to go along with the mean being our measure of center. And the mean, which we had in those boxes on the last page, was 77.5 points. And our spread, we're going to mark down the range, because we always want to use the range, and we're going to pick the standard deviation. So our range came out to be 19 points. And our standard deviation was 3.8 points. Okay, now the chart down here looks like it's confusing. All this is a percentile chart, and then we're going to make a graph, but it says a graph of percentiles, and that's not entirely what it is. It's actually percentages. Okay, so first of all, let's talk about what this means. This means cumulative. So when I'm at the first thing, I only have 1. But when I get to 70, there are 2 items. How do I figure that? 1 plus 1 and 2. When I get to 71, there are now 1, 2 plus 2, so there are 4 items. So 2 plus 2, 4. When I get to 72, there are 6. When I get to 73, I'm adding 6 plus 3, that's 9. 9 plus 4 is 13. And I'm going to continue all the way across with that pattern. Okay, so that gives me a total of 61 data points because there's 61 students in the class. Now down here that says tile, that means percentile. So if I am at 1 out of 61 students times 100, that's what's going to go right there. So I'm just going to pick up my calculator and I will do 1 divided by 61 times 100. And I'm going to round that percentile off since it's 1.6 to 2%. Now I'm not going to write the percent every time, okay, but that's what it is, 2%, okay? Then I'm going to move on to the next one. That is 2 divided by 61 times 100, and that goes right there. So 2 divided by 61 times 100 gives you 3.2, so I'm going to round that off to a 3. Now I'm going to keep going across using my calculator. Again, pause it so you can do some of these calculations yourself and make sure that everything's okay with these. Remember, if they're not, you send me an email and you say, day 6, problem number 6, what the heck are you doing on that? And I will be happy to answer that question. So again, I've already done these calculations beforehand. You can also find them in the answer key, but it doesn't explain how you get them. Okay, so now it says it wants me to graph individual percentages. Okay, so let's do that. So I'm going back to that same histogram style that I had to start with. Okay, so my very first histogram that I made, just to remind you, it was the one where at the bottom, I started over here and I had like, there's 60, 1, 2, 3, 4, 5, 65, 66, 67, 68, 69, 70, 75, 80, 85, 90. Okay, so let's talk about what goes up here on the sides of this graph. So I want to know for my very first item, which is test score of 68, what percentage of the data is it? So there is 1 out of 61. So in order to do 68, I'm going to do 1 out of 61. And that will give me 0.02. So on the side here, when I'm making my table, I'm going to do 0.02, 0.04, 0.06, 0.08, 0.1, 0.12, 0.14, 0.16, 0.18, 0.2. Okay, so for my very first value, which was a test score of 68, I'm going to come over here, I'm going to go to the very first mark, which is 0.02. Now there's only one item also for 70, so that will have the exact same bar over it. Now when I get over here, that is 2 out of 61, so my percentage, 2 divided by 61, is 0.03. Then I get to the next one, that's 2 out of 61 also. Then I've got 3 out of 61. That's 0.05. And I'm just going to keep building my sad little graph, going all the way across, doing each of these percentages. So I'm taking the number, the count, and I'm dividing it by 61 because there's 61 items, and then I'm graphing that. Now when you get done making that graph, your graph will not look this pretty if you're doing it by hand. Now if you're doing it with Excel, it might look that pretty, but you'll notice it looks exactly the same as the previous graph that we did. Let me show that one to you. There's a graph we did just moments ago. This was count of students, and this is count by percentage. I think this one's incorrectly labeled. Okay, but you'll notice it has exactly the same shape. All right, now the reason these are the same is because the spread of the data has not changed. All that I've done is change the scale on the side. Okay, so that takes us all the way through problem 8. Let me find my stuff for problem. Okay, so here's our last group of stuff for today. These are calculating z-scores. So just to remind you, the z-score is z equals x minus x bar over sigma. Now I'm going to calculate the first couple of these with you by hand just so you can see what it looks like. But after that, I'm going to kind of leave you on your own to do it. So for my very first one, I'll do 68 minus, now I need the mean, and I calculated the mean earlier as being 77.5. Over the standard deviation, which I calculated to be 3.8. All right, now when you go to put this in your calculator, the easiest way to do this is to make it so that you are using the fraction button on your calculator, which you certainly, I'm encouraging you use the fraction calculator button. But let's say that your calculator doesn't have fractions, just put parentheses around it. So 68 minus 77.5, close the parenthesis, divided by 3.8. All right, when you do that, you should get a negative 2.5. Now you're going to go to the next one. So I'll just do second enter, and I'm going to change that first value over to a 70. And I get negative 1.97. All right. right, and then I'm gonna go back again and I'm gonna change that to a 71. And I get negative 1.71. All right, so at this point, I'm gonna let you run those calculations out yourself so that you get really comfortable making all your calculations. So please make your calculations, go all the way across. Yeah, a little slow and a little tedious, but you know, we're not going to do this every day of the week. We're just going to do this one time, so it shouldn't be too bad for you. Okay, so we're going to sketch the graph of our z-scores, and I'm going to tell you this is going to be pretty not exciting. It's going to look just like the graphs you have been making. I mean, almost dead on. The only difference is we're going to do some, we're going to put the count over here on the side. So the very first value that we have that we're going to be doing is, so this is count of students with certain z-scores. It's just not a very exciting graph because what you're doing is graphing this and this. So let's go ahead and let's make our graph. So I'm going to have to turn this sideways just to write the numbers because they are 3 digits. So I have negative 2.51. Then I have nothing for 2.2. Then I have 2.0. Then I have 1.7. Oh, I should make those negative. Otherwise it won't come out right. 1.4. 1.2. Negative 0.9. Negative 0.7. Negative 0.4. Negative 0.1. 0.1. 0.4. 0.7. 0.9. 1.2. 1.5. 1.7. 2.0. 2.3. and 2.5. Okay, now what are you going to put for the count? The count goes up as high as 7, so 1, 2, 3, 4, 5, 6, 7. So I have 1. Then I don't have anything at 2.2. Oh, sorry, 2.2 is right here in the middle. 2.0, I've got 1. Negative 1.7, I've got 2. And I'm just going to keep making this graph going along here. I got 2 for the next one. Then I have 3. And you just keep making your graph. Okay, now when you've got that graph all done, it will look like this. And if you can notice, that looks exactly like the last 2 graphs we made. So all that we're doing here is we are just changing the values at the bottom this time. So instead of them being in terms of the test scores, it's in terms of a z-score, but the spacing on everything is going to be the same. So what should you draw from this whole experiment that we just did here? That the original graph, it showed the values and the actual count. So the values meaning the test score of the data. When you looked at the percentile graph, that showed the percentage. It's also called a percentage distribution frequency graph. And our final one was our z-score graph, and that one was standardized, so we took off all of our scaling on that one and made it standard. What's the same on all of these? Every single one of them had the same shape. So the shape of the original distribution was preserved across all three graphs. The percentiles and z-scores are used to calculate the cumulative probability of the data. That's kind of that last thing you should get out of this, and we will spend more time going over like what does all that mean when you take a look at it a little bit later in some future stuff. But the main thing you're supposed to take away from this is changing our scale didn't make any impact on the shape, because your score relative to another person in the class is the same all the time. So if you have any questions, please don't hesitate to send me an email about stuff, and I'll be happy to answer those questions. Otherwise, I just hope you have a wonderful day. Oh, and my little shoulder pork says hi.